Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers, subscribers, and viewers. There is another problem on complex TRUSS solved by substitute member method. And in the preceding video, this problem was solved considering all member forces. And this time, we only consider few members so that the solution will fit in this just one page. So determine the member forces of BG, AD, and CF in this complex truss by substitute member. So the suggestion is substitute member BG by member CG. So we substitute member BG by member CG as shown. So we remove this and as shown. So for the first space, I'll put the uh, procedure here, where to start, where which joint we start, then in the second phase also. So summation forces X, the reaction will be 60, and AY, I just leave it to you to solve for AY. You sum up moment about F, then RF, you sum up moment about A. So this is 60 kilonewtons, 102.5 kilonewtons, just like in structural analysis 2.8, and this is 117.5 kilonewtons. So because we remove this BG here, automatic, there are two unknown forces left, BC and AB, so these are all zeros. So in the first space, AB is 0 and BC 0 also in the first space. We then proceed to joint A. So this is 45 degrees, arctan of 9 over 9, so 45 degrees. Summation forces Y. So in the first space, let's have A, D, E, F, G, because we are already through with joint B. And since by principle, if there are only two forces, concurrent forces, unknown concurrent forces in equilibrium, then those two forces would be zero, unless otherwise they are collinear. So A, summation forces Y first to solve for AD. So SAD sine 45 degrees plus 102.5 equals 0. So SAD is equal to negative 144.957 kilonewtons. Summation forces X equals 0. SAG plus negative 144.957 cosine 45 degrees equals 60, or minus 60 equals 0 or equals 60. Then SAG is equal to 162.5 kilonewtons. We then proceed to joint D here. FBD would be as shown. Then this angle is 45 degrees. The angle that DE makes with the horizontal is arctan of 6 over 3, so 63.45 degrees as shown. Summation forces Y first to solve for SDE. Negative SDE sine of 63.45 degrees, then minus SAD, so minus quantity negative 144.957 sine of 45 degrees minus 50 equals 0. So SDE can now be computed. It is equal to 58.697 kilonewtons. Then we sum up forces horizontal, so negative SCD, then negative of quantity negative 144.957 cosine 45, then plus SDE, so plus 58.697 cosine of 63.435 degrees equals 0. So SCD is equal to 128.750 kilonewtons. We then proceed to joint E. FBD will be as shown. So angle here is 63.45 degrees, while the angle that EG makes with the horizontal is arctan of 3 over 6, and that's 26.565 degrees as shown. So first, summation forces X to solve for SEG. So negative SEG sine of cosine of 26.565 degrees rather. Then minus SDE, so minus 58.697 cosine of 63.45 degrees equals 0. Plus 60 equals 0. There is 60. So SEG is equal to 37.734 kilonewtons. Summation forces Y equals 0, negative SEF, then minus SEG minus 37.734 sine of 26.565 degrees, then plus SDE plus 58.697 sine of 63.435 degrees equals 0. So SEF is equal to 35.625 kilonewtons. We then proceed to joint F here. FED will be as shown, then angle 45 degrees here. Summation forces horizontal first to solve for SFG. Then we check vertically if it is in equilibrium. Because, summation forces vertical first to solve for SEF. We haven't yet solved SEF. So SEF sine 45 degrees plus SEF, which is 35.625 plus 117.5 equals 0. So SEF is equal to negative 216.551 kilonewtons. Summation forces horizontal equals 0. So negative SFG plus SEF, which is negative 216.551 cosine 45 degrees equals 0. So SFG can now be computed, and it is equal to 153.125 kilonewtons. Then check vertically. We proceed to joint C. The free body diagram will be as shown. So this angle is 45 degrees. The angle that CG makes with the horizontal is arctan of 9 over 3. Arctan of 9 over 3 is 71.565 degrees. I just put it here. So to solve for this force, summation forces X, SCG cosine 71.565 degrees plus SCF plus negative 216.551 cosine 45 degrees plus SCD 128.75. Then because this is 0, so no more equals 0. Solving for SCG, SCG is equal to the substitute member, which is 77.079 kilonewtons. Then since everything is known, we sum up forces vertical if it is in equilibrium. Let's check. So summation forces Y is negative 77.079 sine 71.565, the Y component of this member. Then negative SCF, so negative of negative 216.551 cosine of sine of 45 degrees rather. Then minus 80. So calculating, this becomes positive. Summation versus Y is 0, so that's okay, meaning to say the preceding calculations are correct. Preceding values, member forces are correct in the first space. Then we proceed to joint G, the last joint, the free body diagram would be as shown. So summation, this is arc 26.565 degrees, and the angle that this member makes with horizontal is 71.561 degrees. Summation forces horizontal, let's check joint G, equilibrium of joint G. So summation forces X is first SEG, which is 37.734 cosine 26.565 degrees plus SFG plus 153.125, then minus the X component of CG, which is minus 77.079 cosine of 71.565 degrees minus SAG minus 162.5. So checking summation versus X is 0. So that's okay. Then summation versus Y, let's also check. So first, 37.74 sine 26.565 degrees plus SCG 77.079 sine of 71.565 degrees. Then no more, then minus 90. So checking summation versus Y is also 0. So that's okay. So the first phase, these are the values. Let's proceed to the second phase. And joints to follow would be B, A, D, E, F, G. So in the second phase, we simply put the force of BG and we will call that Q as shown here. So you have Q, then solve all these member forces in terms of Q, including CG, the substitute member. And remember that CG is just invented, it is not in the truss, original truss. Therefore, its stress final force would be 0. So first phase plus second phase would be 0. So the angle at B, these are the angles, call that SBC, SAB. So first, summation forces horizontal to express SBC in terms of Q. So SBC cosine of 63.45 degrees plus Q cosine of 26.565 degrees equals 0. So SBC is equal to negative of 2Q. Summation versus vertical equals 0. Negative SAB downward minus Q sine of 26.565 degrees equals BC SBC sine of 63.45 degrees. So equals negative 2Q or plus negative Q 2Q sine of 63.45 degrees equals 0. So expressing SAB in terms of Q, SAB is equal to negative 2.2361 of Q. We then proceed to joint A, and the free body diagram would be as shown. This angle is 45 degrees. So first, summation forces vertical to determine SAD. SAD sine of 45 degrees plus SAB, which is plus negative 2.2361 Q equals 0. So SAD is equal to 3.1623 of Q. Summation forces X equals 0. SAG plus 3.1623 Q cosine 45 degrees equals 0. So SAG is equal to negative 2.2361 of Q. We then proceed to joint D as shown, and the free body diagram will be as shown. This is 45 degrees. Angle that DE makes with horizontal is 63.45 degrees as shown. So first, summation forces Y. So negative SDE sine of 63.45 degrees. Then minus SAD, which is minus 3.1623 Q sine 45 degrees equals 0. So SDE in terms of Q is negative 2.500 Q. Summation versus horizontal 0, negative SCD. Then negative of SAD, so negative of 3.1623Q cosine 45, then plus SDE, so plus quantity negative 2.5Q cosine of 63.45 degrees equals 0. So SCD in terms of Q is equal to negative 3.3541 of Q. Then uh, we proceed to join E. Free body diagram will be as shown. So angle here 63.45 degrees. GE or EG makes with horizontal an angle of 26.565 degrees. So first summation forces horizontal equals 0, x equals 0. So we have SEG, negative SEG cosine 26.565 degrees, then minus SDE, so minus quantity negative 2.5Q cosine of 63.45 degrees equals 0. So SEG is equal to 1.250 of Q. Then summation forces vertical equals 0. We have negative SEF, then negative of SEG, negative of 1.25Q sine of 26.565 degrees, then plus SDE sine of 63.45, so plus negative 2.5Q sine of 63.45 degrees equals 0. So SEF is equal to negative 2.7951 of Q. So we proceed to joint F. FBD will be as shown. Angle here is 45 degrees. Summation forces vertical first. Horizontal, no, vertical first to solve for SCD. So from the figure, SCD sine 45 degrees, SCF sine of 45 degrees rather, plus SEF, which is negative 2.7951Q equals 0. So SCF is equal to 3.9529 of Q. Summation forces x equals 0. Negative SFG plus SCF, so plus negative of 3.9529Q cosine 45 degrees equals 0. So SFG in terms of Q is negative 2.7951 of Q. Then we proceed to join C and angles, remember, from here. So first summation forces vertical equals 0 or horizontal equals 0. Then let's check vertically. So we have SCG cosine of 71.565 degrees plus SCF, so plus 3.9529Q cosine 45 degrees plus SCD plus negative 3.3541Q, then minus SPC, so minus quantity negative 2Q cosine of 63.45 degrees equals 0. So solving for SCG, SCG is equal to negative 1.0608 of Q. Then let's check vertically, summation versus Y. So we have negative of negative 1.0608Q sine 71.565 degrees minus SEF, so minus 3.9529Q sine of 45 degrees minus SBC, so minus negative 2Q sine of 63.45 degrees. And checking summation versus Y is indeed 0. So, okay. Then we proceed to join G, FDD. So check summation versus X. This is the last joint. So we just check equilibrium of joint G. Summation versus X is SGE or EG 1.25Q cosine of 26.565 degrees. This is 26.565 degrees. plus SFG, which is negative 2.7951Q, then minus SCG, so minus negative or minus Q cosine 26.565 degrees, then minus SAG, and SAG is negative of 2.361Q minus SCG minus negative 1.0608Q cosine of 71.565 degrees. And checking, everything is in terms of Q, so summation versus X is indeed 0. So, okay. Finally, we check equilibrium along Y, summation versus Y. So we have SEG, which is 1.25 Q sine of 26.565 degrees plus Q sine of 26.565 degrees, or plus SCG, which is negative 1.0608 Q sine of 71.565 degrees, then plus Q sine of 26.565 degrees. So I put the results here. Summation versus Y is indeed 0 or almost 0, so that's fine. Because we have shown that the last joint is in equilibrium, so we are sure that all these calculations are correct and the values are also correct. We then equate the stress of CG to 0, first phase plus second phase equals 0. The first phase value is 77.079 plus negative 1.0608 Q, second phase value equals 0. So from here we can solve for Q, which is stress in BG. Q is SBG equals 72.661 kilonewtons as compared to the solution preceding to this in structural analysis 2.8, which was 72.669. So they are practically equal. Then for SAD, first phase is negative 144.957 plus second phase 3.1623 of Q. So negative 144.957 plus 3.1623 of 72.661. The answer for SAD is equal to plus 3.1623 of Q, which is 72.661. So again, SAD is negative 144.957 plus 3.1623 of Q, which is 72.661, and that is 84.819 kilonewtons. Okay, then CF first phase is negative 216.551, then plus 3.9529 times 72.661, and we'll get SCF equals 70.671 kilonewtons. So that's it for this video. I hope that you gain another technique in analyzing space thrust by substitute member.